we start our discussion about thin lenses, because this becomes the basis of all of our work in this chapter. Now, lenses come in different sizes. With mirrors, we had basically two possibilities. With mirrors, we had concave and convex. But with lenses, we have multiple sides. We have two sides, so it gives us more freedom. We have the double convex, which is the two bulging lenses, sides out. We have the plano-convex, the convex meniscus. And so you notice that with the plano-convex, you have this flat surface on the back side. And with the convex meniscus, it's like this second side has been turned into a concave layer. Now, we're not going to play with these plano-convex. Causes too many problems because everybody doesn't like this flat side, because what this means is that the radius is infinite, and it causes all sorts of people running to Professor Rallone complaining about this. So I just don't worry about this one too much. That all the things will apply, except you just have to make this radius infinite when you do the calculations. This becomes the basis for everything. The double convex. This is what we define everything that we're going to do off of in this chapter. And the convex meniscus, we'll find uses for that. We'll play with that. Now, the other set of lenses that we have are the double concave, which just has the sides of the lenses bulging in. The plano concave, which is the same. We're not going to play with this one. And then you have the concave meniscus, which is similar to the convex meniscus in that there's this inside radius with an outside radius. So this concave meniscus and convex meniscus are very similar to each other, and it really just depends on the radius that are provided. Now, everything that we're going to do with lenses is going to be very similar to what we did with the mirrors, and that we're going to have ray tracing. So the lenses are going to have a focal point just like we had with a mirror. But the interesting thing about lenses is they actually have a focal plane, meaning that depending on how I look at the through the lens, I get this plane in the background where everything becomes in focus, depending on which way I look through the lens. So this is something different, but we're just going to base everything we do off of this axis, and we'll just know that everything, depending on how we look in the lens, will be in focus. This will simplify our analysis and our problems. Also, too, you can see that with the double convex, that the focal point and the point where everything merges is on the other side of the lens. This would make this a real image. But with the double concave, notice that the focal point is on the back side, the side that the incoming rays from the object are going. And so because of this, you get this diverging rays on the other side, and the focal point in the image then becomes virtual. And we will investigate how this happens. We'll come up with equations so that we can solve these. Now we're using what's called the thin model, thin lens model, because it simplifies a lot of our calculations. So this just means that R is very large compared to the height of the lens. So in these problems, we'll have to remember that the lenses are pretty small, the radiuses are quite a bit bigger. So let's look at how we can define some properties of our lenses based on the double convex lens.